Okay, thanks, Ben. So my name is Ciara Loftus. I am a software developer with Intel. I'm based in Shannon in Ireland. And my background is I'm a developer, so the project that I commit most to at the moment, as you might have guessed, is OPNFV VSwitch, particularly the DBDK accelerated part of OVS. But today, as Ben said, I'm here to talk about test. And I'm going to be talking about kind of my experiences as a developer with the test tool VSPERF. So VSPERF was referenced in multiple presentations yesterday and even during the DBDK summit on Tuesday and Wednesday. So I'm guessing some of you are kind of familiar with the term at least. Some of you might have tried it. You might kind of have an idea of what it can and can't do. So I'm just going to kind of build on that and give an overview of the tool and kind of talk about how it's been useful in kind of my life as a developer for OVS. Okay, so I'm going to talk about what I've called it my shameful past with an emphasis on the SH. This is kind of a slide to describe my past testing practices. So, like I said, I've been contributing to OVS for 3 or 4 years now. And for the majority of that time, I've been writing and performing my own suite of tests on kind of features that I'm developing or when I'm testing other features. So I say suite of tests, which sounds really organized and everything, but the reality is quite the opposite. So this is the output of a recursive ls on the scripts directory on my development machine. And believe it or not, that's only maybe 10% of the output. I couldn't fit it on the slide. And if that isn't clear to everybody in the room, it's basically a long, awful list of bash scripts. So it's pretty shameful. And kind of how I got to that point was through poor process. What I used to do for every feature that I was either developing or testing, what I do is I'd clone a kind of old set of scripts, modify them slightly, run them, forget about them, and let them go stale. So naturally enough, after 3 or 4 years, I had accumulated hundreds and hundreds of very similar bash scripts, but with no naming scheme, no organization, and just no rhyme or rhythm to the process whatsoever. So you're probably trying to look through the names of some of these scripts. You might see there's quite a bit of duplication, so I've probably written the same test 20 times, which isn't very efficient. Lots of ambiguity and nonsense, so the names of some of these scripts they kind of baffle me at this stage. Really obscure, like bug.sh or flow.sh. I don't know what any of them do. And then this one up here, I didn't plant it. I was just looking through the slide and I spotted this fail.sh, and I think that pretty much sums up my old testing practices. So that's kind of what led me to VSPERF. I kind of thought, right, the way I'm going isn't very good. If I keep going like that, I'm going to run out of memory on my development machine if I have all these bash scripts. So I kind of looked into VSPERF, which is a test framework, and I'm just going to share my kind of experiences with it now. So a brief overview, like I said, you might have heard about the tool before, so it's part of the Linux Foundation's OPNFV project, so it's open source. The VS, as you might have guessed, stands for vSwitch, and the PERF for performance. And it's basically a benchmarking and test tool for virtual switches. So not just for OVS, it's actually vSwitch agnostic, meaning that any other vSwitch can be theoretically supported, and indeed many are. But I myself use it pretty much just for testing OVS and OVS DBDK. So it's a Python-based framework, so I'm moving away from my beloved Bash. And it's got a healthy community with contributions coming from all corners of the industry. Some of them are listed there. There's many more, and I'm sure some of you are probably in the room as well. And a recent milestone was met in that the IETF or FC, I've practiced saying that already, IETF or FC, describing the benchmarking practices and methodologies followed by VSPERF was approved, and that basically just means it got its own number. So I'd welcome anybody with the laptop out, which is probably about 50 to 60% of the audience at this stage, to type into Google RFC 8204 just to find out a bit more about kind of the test setups and configurations followed by VSPERF. But the importance, I suppose, of this RFC being approved and getting its own number is that, like I said, the practices and configurations and methodologies followed by the tool are essentially kind of standardized and recognized. And as a result, the results that the data, or the data that the tool produces has a lot more weight behind it, as regards benchmarks, certainly in comparison with my old testing practices anyways. Okay, so looking a little bit deeper into VSPERF, like I said, there is support for multiple vSwitches. So we can test native OVS, OVS DBDK, and FTIO's VPP. Then you can use different kinds of traffic generators. So there's support for hardware options like Ixia and Spirent, as well as software options like Xena, TRX, and MoonGen. I think those are open source. And VNFs, so there's lots of VNFs you can try, like DBDK's Test PMD, which is a popular one, Linux Bridge, PCI pass-through. And the great thing about VSPERF is that it's always being extended. So theoretically, the infrastructure is there to plug in any new vSwitch, traffic generator, VNF, and the community are definitely open to kind of embracing these new technologies and integrating them into the framework. Then as regards tests, so I've grouped the types of tests in VSPERF into 3 different categories. There's lots of different types or lots of different tests you can run. So I've grouped them into performance, functional, and comparative tests. And I suppose, depending on who you are and what your motivation is, different tests in each of these categories will probably appeal to you. So take me, for instance, a developer. When I'm submitting code to the OVS mailing list, I might use VSPERF to run some of the performance tests to make sure I haven't introduced a regression with my changes. And I might run some of the functional tests to make sure I haven't broken anything. And I might even write my own functional test just to make it easier during my development process. But then take somebody else, maybe a network operator or somebody who's looking to upgrade their infrastructure or move to NFV. They might use VSPERF to perform some comparative testing between the different vSwitches, try them out in their environment for different use cases, different traffic profiles, and use the data generated by the tool to maybe drive a decision on which one to use. Okay, and I'm going to go into a bit more detail on those three categories now. So performance testing is probably what VSPERF is most famous for. The hint is in the name. The most useful performance test, in my opinion, that VSPERF offers is the RFC 2544 throughput and latency test. It was touched on yesterday as well. Most people are familiar with it. It's also known as the 0% packet loss test. And this test will tell you the rate at which the switch can forward packets without any drops, and the associated maximum and average latency values at that rate. And it's generally a good baseline indicator for vSwitch performance. And that test and the other tests can be run on different types of topologies. So if you're interested in kind of switching packets north-south between a NIC and a VM, you can set it up like that. Or if you're more concerned with east-west traffic between VMs, you can set that up. Or multiple combinations of that, like VMs in parallel or VMs in series, loads of options there. And of course, each of those will have their own associated performance profile. And then, again, with every test, there's loads more things you can configure, mostly around the kind of traffic type. So you can change things like the packet size, packet type, pretty much any field in the packet header, the number of flows, how long the test runs for. You can even kind of simulate some stress on the system and see how the vSwitch adapts. So there's lots there to configure. And one way that we have used the performance tests in our lab is to run them nightly on the head of OVS master. This is fake data, by the way. So we run them nightly on the head of the OVS master branch. And then in the instance of a regression, we can pinpoint the date, do a bit of detective work with the Git log using my favorite tool, Git blame, and figure out which was the offending commit, and then maybe propose a fix or propose that the commit is reverted. So it's pretty useful for tracking kind of historical performance. But VSPERF is kind of, right now, has a lot more to offer than just performance testing. Something that has been added recently, which I find quite useful in kind of my life as a developer, is the functional tests. So a patch, for instance, was submitted recently that kind of performs some regression tests on the OVS DBDK software. So there's 14 features listed there, and there's, I think, 59 tests among them. And basically, these tests validate specific functionality in OVS DBDK. So things like port hot plug, jumbo frames, vhost user, NUMA awareness, vhost user multi-queue. There's a huge list of tests. And the value of these automated tests kind of really comes to light when you're making a big change to OVS DBDK, when you're doing something like upgrading the DBDK version. So whereas before you would have had to go in and manually validate all of these features individually, which is a huge time sink, now you can just run a single command, kick it off, go about your day, and come back later and check the results. So it's a huge time saver. And I can definitely vouch for that because we're in the middle of a DBDK upgrade at the moment from 1705 to 1711. If you were at the DBDK summit earlier this week, you would have witnessed the tagging of the 1711 branch. But so yeah, we're using these tests at the moment to validate new patches and new release candidates. And yeah, they're a lifesaver. And so I've linked the patch at the bottom of the slide there, and if you check it out, you should hopefully be able to see that it's quite easy to add new tests. I certainly was surprised myself. And I'm going to give a little demo that hopefully backs that point up. But it's not really a live demo. I wasn't brave enough. It's not even a video of a demo. It's just some screenshots and PowerPoint animations, so please use your imagination for this part. So the test, I'm going to show you how to write a test. So the test that we're going to implement is to validate the EMC insertion probability OVSDB parameter. And we're going to set that parameter to disable the EMC. We're going to send some traffic, and we're going to measure the performance, and we're going to make sure that the EMC wasn't hit during the test. So it's kind of both a performance and a functional test. The EMC, by the way, I think it was described yesterday, but it's the exact match cache, which is the kind of first lookup table used by a packet during classification in OVS. And generally, when you disable it, you're going to see a performance decrease, at least for kind of small numbers of flows anyways. Okay, so I don't know how clear this is, but I'll hopefully do a good job of explaining it. So the first bit is just some basics. The name of the test, the deployment. So here we specify P2P, which stands for physical to physical. So we're just looping packets between two physical ports. Just as easily, you could say PVP to loop up into a VM. You could specify what VNF you want to use. You could do PVVVP if you want to do loads of VMs in a chain. But for this one, we're just going to use a simple P2P test and a description of the test. Next up is the OVSDB. So we're using a DBDK, OVS DBDK in this test. So we specify to initialize it. We give it a core mask. And this is the important one here. We set the EMC insert to 0. And that should disable the EMC. Then we set up our traffic. So for the purpose of this test, we just want a simple kind of default traffic type where we're going to run it for 5 seconds. But again, you could build this out to, say, the packet size. You could specify a destination IP address, whatever you want. And then finally, these test steps down here, these allow you to execute a shell command. So what we're going to do, this is for kind of step 4 in the test. We're going to execute OVS app-kettle and print the PMD stats. We're going to grep for EMC hits, and if it equals 0, then the test passes. So that's it. That's the test. And then to run it, you just run the VSPERF command line and specify the name at the top of the test. So it's pretty easy. And if it doesn't look easy, writing your second test is always easier than writing your first. So once you've written one, basically it's pretty easy to write more. And then on the functional tests, that's probably something that we'd look to include into our continuous integration alongside the performance tests if they get upstream. Okay, and then finally, VSPERF comparative benchmarking. So as I mentioned already, there's support in VSPERF to test native OVS, OVS DBDK, and FDIO's VPP. And comparing them using the tool is very easy. So you just execute the same tests for each different vSwitch and compare the results. Simple as that. And to change whatever vSwitch is used in any test in VSPERF, you just modify this vSwitch parameter either on the command line or in the configuration file. So very easy stuff. So I was debating whether or not to include some data from the tool that shows how the different vSwitches line up against one another, and I'm sure everybody would be really interested to see, but I thought that that would kind of distract from the message that I want to get across, which is about the capabilities of the tool. But I'm pretty sure the data is public. There's an OPNFV continuous integration, so you can grab the data from there, or the tool is open source, so you can try it out for yourselves if you want. What I've done instead is I've just shown some theoretical data of how VSPERF could be used to simulate two different use cases and perhaps help someone make a decision on which vSwitch to use for a particular use case. So what you could do here is if you had a cloud use case and a telco use case, often they'll have quite different requirements as regards throughput and latency, and you'll see different types of traffic in one of the use cases and different types of traffic and protocols and packet sizes in the other. So you could use VSPERF to model those two use cases as best you can with topologies and traffic types. And what you'll often find is that a different vSwitch will come out on top for the different use cases. So that's just one way VSPERF could be used to kind of do a bit of evaluation. And then I think everybody knows what I'm going to say here, but when you are comparing anything, and when you're comparing vSwitches, it's really, really crucial that you compare apples to apples, and you hear this term all the time. But I know from experience that I've seen benchmarks in the past that pitch different vSwitches against each other. And when you look into the details, you'll find out that one vSwitch might be doing like a patch pretty much and not doing any matching, and it'll have great performance. And the other vSwitch might be doing matching on like L2 and L3 and everything. So the results aren't really reflective of the real world use cases. So that's just something to keep in mind when you are performing comparisons with VSPERF or with any other tools. Okay, and then a bit of a lazy conclusion. I've just flashed up some of the benefits of VSPERF that I've certainly found over the last couple of months through my use, and hopefully that have become apparent during the presentation. It's definitely been a success story for me. I'm not quite yet to get rid of my lump of bash scripts. They're kind of a comfort blanket at the moment. I'm worried there's a special script in there that I'll need a year or two down the line. But for the most part, in my kind of day-to-day life as a developer, VSPERF has really been useful. So hopefully some of you are inspired to try it out. And that's it. So I'd be happy to answer any questions if there are any.
All right, we do have time for questions, so fire away.
This is awesome. I really love it. Thank you so much. So I haven't played with it, to be honest. And to play with it, just the minimum setup, what do I need to have? Is that a vSwitch and the guest? Is that good enough?
So the minimum setup, so probably a vSwitch, maybe a NIC, you could, an open source vSwitch, an open source traffic generator. You don't need any hardware traffic generator or anything. So you can get up and running quite quickly so long as you have a platform. Maybe you don't even need a NIC. You can probably do tests with just VMs. So yeah.
Thank you.
Hi. Do you have TestPMD as a vSwitch as well?
Sorry?
TestPMD as a vSwitch.
TestPMD as a vSwitch. So you mentioned that yesterday in your talk. I wasn't aware that was
because we have it. Maybe we forgot something, but
yeah.
TestPMD, this is a vSwitch as well.
Yeah, it's debatable whether or not it's a vSwitch. It doesn't do much matching, but yeah, it probably should have been included on the slide. Yeah.
Yeah, I was just wondering, does this test suite has the ability for you to specify, the optimal host configuration, like, NUMA pinning and pinning VP to logical processors and things like that?
Yeah, so I think that there's a bit of intelligence there that will kind of check your CPU, like which CPUs are on which NUMA nodes, and try and pin it all to the same one. I'm pretty sure there's a bit of intelligence there. It mightn't be the full shebang, but yeah, there's kind of optimizations there. Yeah.
Oh, so there are options to
Oh,
specify out-of-box configuration versus, like optimal
Yeah.
host configurations?
And it's all configurable yourself. Like if you have if you want to affinitize everything to a certain NUMA node or run on specific cores, it's all
So you
possible.
do that before? You have
Yeah.
to do that prior to the test?
Yeah.
Okay. Is there an option to, as you see it, is it easy to add a plugin to do something where you can say, like, on Linux or on Windows that, we have an option to, because sometimes people who run it, they don't really know what's the best way to optimize for benchmarking.
Yeah, so I think there's kind of basic optimizations there at the start, but you might need to do your own kind of specific stuff as well. I'm not sure about Linux and Windows. I'm pretty sure it's only been run on Windows, so I'm not sure about that. So, yeah.
Thanks.
No problem.
Hi, here, this is Yi Yang.
Oh, yeah.
My question is, for DBTK, we have a standard performance test. When we release a new DBTK, we have performance data for public. But for OS, we don't have this performance data, right?
So are you saying kind of for OVS releases, we should?
I mean, for OS release, we don't have any performance data.
Yeah.
Yeah, right. I think that is a problem.
That's a good idea. Yeah, we could use the tool
Because we have VSPERF for OS performance test, right? If we have a new release, I think we have test new release and release performance data for public. And anybody can compare this release performance data with the old one, right? Then can make sure every people can know which release is better.
Yeah. Hopefully the newest release is the best.
Yeah,
but, that's a good idea. Yeah, definitely.
Just a quick question. In your demo here, you haven't covered the setup phase where you are inserting rules in the rule set that you have used, right? I guess the tool can have any rule set, right?
It can have any
Rule set to insert in the OVS.
Any rules? Sorry, I didn't have.
I think he's asking what rule set, what set of flows.
Oh yeah, you can configure whatever you want.
But
Yeah.
you haven't covered that. But there is a setup phase first for the box, right?
Sorry, it's hard to hear.
There is a setup phase first to insert the rules in OVS.
There's a set of fields to.
Phase setup. Phase.
Sure, I follow.
Yeah, okay.
Can we talk offline? I'll grab you there. No. I'll come find you.
Thanks for the great talk. And when you see that this test framework is agnostic to virtual switching, I'm just wondering how that can be done. See, OpenVSwitch and the VP have very different kind of control command line to provisioning. So can you talk a little bit about how it can be agnostic?
Yeah, it's a challenge. So initially, I think it was just OVS and OVS GBDK that were supported, and they're obviously quite similar. But when VPP was plugged in, there's essentially kind of generalizations of functions like adding a physical port, adding a virtual port, adding a flow. Like in OVS, that would be with OVS OF kettle, but in VPP, that would be with VPP kettle, I think it's called. We try and kind of get it as equivalent as possible and try and generalize the kind of main functions for each vSwitch. There'll be small kind of intricacies that don't completely line up, but the kind of code and the configurations are all open source, so you can compare, how one vSwitch is set up and how another vSwitch is set up. But yeah, it's kind of through generalizations of those kind of fundamental vSwitch functions, like adding a flow, adding a port, stuff like that.
Okay, thanks.
All right, let's thank our speaker.